welcome back, guys. Welcome to the second video. Right, we will continue from where we left off in the first video. So we talked about the categories: structured, semi-structured, and unstructured data. Right. If you have any doubts, do post it in the comments, and I'll make sure to answer that. Now, guys, the another topic is, so how the data is stored. If I talk about this structured data, right? If I talk about this table, what do you think we have available in the industry to store this type of data? So, of course, we have databases, right? We have databases. Now, when we talk about databases also, so under databases, we have categories, right? We have either relational databases, right? And we have non-relational, non-relational databases. When we talk about relational databases, so we can think of, right, the most common which we have is SQL database. And of course, we have other vendors also, but this is the main, you know, application or the main database from which we understand that okay, it has rows and columns kind of a structure. It has a schema, or it can be queried using a SQL language, SQL query language. Then we also have non-relational databases, right? Under non-relational databases, we generally have key and value pairs. Guys, remember we talked about JSON in the last video. So generally the key value kind of pairs can also be stored as a JSON kind of data, right? But there are databases for that, right? For example, if I specifically talk about Azure, then we have Cosmos DB for that, right? And one another non-relational database which is very much used is our Graph DB. Cosmos DB also have API for graph databases. Guys, what is graph database? So when we want to display some sort of information which defines relationships. Okay, again, I can add maybe one more column here, or okay, let's say not a column, but I want to define a relationship between Chavi and Arun, or relationship between Arun and Simran, or relationship between Chavi and Simran. So what type of database I can use to display or store that kind of an information? So I can use a graph database for that, right? Graph database generally has what do you call them? Nodes, right? We have nodes, and we use arrows generally to define the relationships, right? Okay, I am not writing it correctly. Nodes, right? Nodes are your entities, right? Entities could be like Chavi is an entity, or Arun is an entity. And then nodes, and we have relationships which we generally define by an arrow. Relationship could be, let's say that Arun is brother of Chavi, right? So guys, we have the non-relational databases and we have the relational databases. Relational is this is a relational database. Sorry, this is an example of relational database only. Apart from databases, guys, we can store the information as files. Now, here you are talking about JSON and XML, right? So these are one kind of a file only. See, it's a, you open a notepad file. The file which I was demonstrating earlier, the JSON file, what is it? It's a notepad file. It's a file. So when you are storing the data on the machine, right, it's a dot json, a file with a dot json extension, or a file with a dot xml extension. Or you will say that, okay, then video is also a file. Yes. What kind of file is it? It is a blob file. What is a blob? A blob is, okay, first of all, just to give you the full form, it is binary large object, and ultimately this kind of data is stored in the form of binaries, zeros and ones, right? um Apart from these, right, apart from these files and databases, uh, if we also have some other kind of formats, right guys? uh, these kind of okay, let's first define these formats. So most of them have been developed, right, developed by Apache, right? And wherever the word Apache comes, I think it might be very I mean obvious to define that they are used, or these file formats are used for big data. Big data, or you can call it let's say used for uh, data analytics, right, or data mining and so on, right? Multiple terms, whichever one you're comfortable with. Now, one of the format which they have, wait, let's use this. So the very first we have is Apache Avro, right? Another we have is an ORC, right guys? ORC is an optimized optimized row columnar, and the last one we have is columnar file, guys, right? As I explained you, they are used for big data, right? They were developed by Apache. So what was the purpose? The purpose was optimized and efficient reading of the data, so that, see, the point is you want whatever database or file you are using to read the data, because uh, you need the performance of your systems to be very fast. You need them to be efficient, you need them to be fast, you want them to have the optimum performance which can be there. So they have to develop such a file system which can be read very easily, or which from which the data can be extracted very easily or at a fast pace. Plus, not only that, when you are storing the data, the storage should be used very efficiently. See, your purpose is to store large amounts of data in a small space. So, how the data can be compressed? You know, all these three formats, they have like they can be compressed. much more compressed, or you can say uh, the this the extent to which these relational databases or these JSON or blob files can be compressed, these Apache formats, they can be compressed at much more extent than these, or they have developed such algorithms that they can be compressed much in a much better format than these. See, because you don't only need the compression, right? If you, even after compressing the data, you need to make sure that you can still read it, you can still extract, you can still analyze it, and your data should not be broken. It should not be distorted at all even after the compression. So it's very important that what kind of compression you are performing, or even the data can be compressed or not, right? All these are open source formats, right? They're developed by Apache. All these three support your multiple development languages, right? Be it Java, C++, or Python, right? Whatever coding languages you want to integrate, like, whichever application you are using and whatever coding or programming platform you use, these are um, compatible with them, right? All right, now this was about how data is stored. Now what is the next topic we have? Our next topic is, okay, now guys, these databases, no, whether it is relational, whether it is non-relational, whether these are the Apache formats, or whether they are the JSON or XML files, the database or the data, I'll not say the word database, I'll say the word data. There are two type of workloads which are there, right? There are two type of workloads. The first workload is your transactional data workload, and the another we have is analytical workload. Okay, when I talk about transactional data workload, the very first thing which we need to understand is the word transaction. What is a transaction? So if I talk in terms of banking, what is a transaction? A transaction is that a sum of amount uh, has been credited or debited in your account. You did a transaction. The money was debited from your account and credited in the vendor's account or in someone else's account. That is a transaction. If I talk in terms of database, what is a transaction? To read a particular item, or to write a particular item in the table, or to delete a particular item from that table, or to delete or update a particular entry in that table. That is a transaction, right? Any operation, guys, what are the operations? We have the CRUD operations, right? You create, you read, you update, and you delete the data in a database. So your database have uh, transactional workload. You perform these kind of actions on your database. It can be read activities, it can be write activities, it can be any delete, update activities, right? And we also use a term here, right? A term is used very much in the industry, right? So this is OLTP, right? We call these OLTP operations. So online transactional processing. Guys, the word online here does not mean that you are online on Skype or Microsoft Teams, or you're online on Instagram or Facebook. No, online means that your database needs to be available when you want to perform an action, right? Online here means that your database needs to be available when you are trying to perform any of these CRUD operations. Okay. Now, uh, when we talk about transactional data workload, right, there is a very, very famous acronym which is to be used here is ACID. What is ACID? So, guys, ACID is it is not uh, exactly, it's not a quantitative measure, but it is more of a qualitative measure of your database. For A, we have atomicity, right? From C, we have consistency. From I, we have isolation, and finally we have durability. Guys, atomicity. Every transaction is a unit of work, right? Every transaction matters. Every credit and debit matters. Every transaction will either fail or success completely, right? So atomicity is every transaction is treated as a single unit of work. Then consistency. Data needs to be consistent. Doesn't matter where you are storing it, it has to be consistent. It cannot display one value at one place and display another value at another place. No. If you have two separate screens, you have two separate systems from which you are viewing the data, it has to show same values from the database. Isolation. Every transaction which is happening at one particular time, or let's say concurrent transactions, each one of them, see, each one of them is isolated in its means, um, they are, every transaction is a whole, they are one whole, they are one single unit of work, they should not interfere with each other, right? It is possible that multiple transactions are happening, you are reading also and the data is getting, okay, data is, we are reading also and we are writing also in it, right? So each of these transactions are isolated, they should not be interfering with each other, the read and write operation should not interfere with each other. And finally, you have durability. Even if your system shuts down and then when it comes up, the data changes should be as they were earlier. Even if you access that data after 1 month or 1 year, it should be same. Of course, I'm ignoring if we make any changes in the meantime, but my point is, let's say you shut down the system, but then you switch it on after 1 month, it should be as it is, it should be durable, right? So guys, that was your ACID. The next we have is analytical workload. Guys, analytical. Under analytical, the terms which we, acha, okay, what do you want to do when I use the word analysis of data? Okay, I'll give you one example. In 1 month, whenever a bread was bought in a shopping mart, whenever a bread was bought, was butter also bought at the same time? You want to analyze this. You want to analyze that, let's say if 100 customers came every day in the shopping mart, and when some of them or all of them bought a bread, did they also buy cream or butter with it, or jam with it, or some sort of sandwich spread with it? Now, why do they want to do this analysis? Because they want to increase their sales, of course, guys. Okay, again, another topic completely. The point is that there is a separate workload which these database systems or these applications have, and that is the analytical workload. And because the data is very very large, right guys, in analytical workload you have dumps of historical data. You will have terabytes of historical data on which you need to perform the analysis, maybe to increase your sales if I talk about a shopping mart, or if not shopping, let's talk about hospitals or talk about diseases and everything, and you want to get a chart that okay, how many persons got this disease at what time of the year, what was the situation, why they got it, and so on. Again, there can be hundreds of scenarios which you can think of. Now here a very common word which you might hear is OLAP, right guys? Just like uh, OLTP was there, we have OLAP, right? OLTP was online transactional processing, whereas your OLAP is online analytical processing, right? Where we want to perform analysis on very very large amount of data, right? Under analytical workload we will hear about words like data warehouse or data lake. Guys, I'll talk about all this, right? In the upcoming videos we will talk about data warehouse and data lakes, right? What is the difference between them and everything. All right,